Okay, I think this is third time lucky. Let's jump into some 3D shape for today. We're going to start off with some names. We're going to then look into some properties. We're going to look at some nets and some tricks you can do for visualizing those, and then we're going to finish with a bit of work on volume for today. Okay, so I have some 3D shapes here. We're going to start top left with our cone. Okay, you might see it in this orientation, you might see it this way around when it looks like an ice cream cone. Either way, this is our cone. Second shape along, we can see if we look at this, we've got a pentagon here, and because it then has a pentagon at the far side, this becomes a pentagonal prism. This little number here looks a little bit like pyramid, except it's only got a triangular base. That makes that a tetrahedron. Here we go, we've got these two, kind of related, but this one here is called our cuboid, whereas this one here is our cube. Difference between them is the same kind of thing as the difference between a rectangle and a square. So we've got our cuboid where all dimensions, all lengths of all lines, all edges are the same. Our cuboid is more recognizable almost as that kind of has that rectangular base or rectangular face on it. Our 3D circle here, a ball, is a sphere. Bottom middle, we've got our square base pyramid, like the ones in Egypt. And then over here we've got our cylinder. Okay, names of our 3D shapes. Obviously with prisms you can have lots of different prisms depending on the shape of the face on the front. So you could have triangular prisms, you can have octagonal prisms, all sorts. And if you kind of look at a cuboid, you can kind of see that's almost a square prism and it's kind of set up there as well. Okay, so some of the properties, we've got faces, edges, and vertices. So if we have a little look at some of these, our faces are the bits that you can see. They're the bits that you can count. For most shapes, they'll be flat. However, in our cone here, we've got a curved face, which comes all the way around. So when it comes to counting faces on shapes, what you need to do is you need to be thinking about how in your mind you can rotate that so that you can see that. My tip for all of those is if you're doing that, almost dot them. So I've got one on the bottom, I'm going to count my bottom face there. Then I've got one on this side, 2, 3 on this one over here. There's one on the back over there, and then there's one on the top. Okay, this gives us 6 faces. For my pentagonal prism down here, I've got a pentagon and I've got a pentagon. One of the things that you can use, one of the properties that you can use with a prism shape is you've got a shape on the front, you've got a shape on the back that gives you 2 faces. And then, however many edges there are around here will give you the number of other rectangular faces which form your prism. So pentagon has 5, which means there's 1, 2, 3, 4, 5 all the way around, which gives us 5, 6, and then 7 faces for this shape here. Okay. Edges. Edges are the parts of shapes that join the faces together. So again, normally if I was going through these, I'd be highlighting these off. So 1, 2, 3, 4. And then I've got another 4 at the bottom. 1, 2, 3, 4. But then I've also got edges which join my 4 faces here. So 1, 2, 3, 4. So that's going to give me 4, 8, 12 edges for my cube. That's going to be the same for a cuboid as well. And those are straight edges on this shape. For my cone, I've got 1 curved edge the whole way around. And that's the only edge I have. I have an apex, I have a point at the top, but I only have 1 curved edge around here. And then for my pentagonal prism down the bottom, I'm going to have my 1, 2, 3, 4, 5, and that's going to be repeated on the other side. So 5 there. And then we can again use that property of the shape to work out that we're going to have another 1, 2, 3, 4, 5 the whole way around. That's actually going to give us 15 edges on this shape here. Okay, so you see kind of the differences there, and again, excuse me, again, you want to be sort of annotating those, drawing those on, counting those up as you're going. The final bit that we've got here to talk about in terms of properties are going to be our vertices. Vertices are in the 3D world, your corners, your points. So if we're going to count them up here, let's use something slightly larger. 1, 2, 3, 4, 5, 6, 7, 8. Missed that one completely. There we go. So that's an interesting one here. In terms of that, here I have one at the top, and then here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on my pentagonal prism. With these, it's fairly straightforward. It's about remembering what the words mean. It's about being able to identify them, but it's also about counting them carefully. Now, for these ones, these are quite simple. These are quite easy to look at, because what you've got is you've got this this dotted line behind, which shows you that it's there. The trickier way of looking at those is if I pop out a cube here. If I drop one of these in where we don't actually have those dotted lines behind, you can see the difference there between them. What you would then have to do is, again, a lot of 3D shape work is all about visualization. So you're almost going to want to kind of manually draw that line on yourself and go, okay, well, actually, if this is a cube, it's going to look a little bit like that. Obviously, with better, straighter lines, this doesn't look as ridiculous as that, but you get the idea. Okay, nets, not fishing nets, but nets of shapes. Net is something that a 3D shape will look like when it's unfolded, when it's folded flat. The reason I've included this one here is quite an interesting one, because it has these little tabs here, because this is actually designed to be a net of something you could cut out, fold up, turn into our square base pyramid over here. And so these flaps here are what you'd put the glue on. Technically, they don't need to be included in the net. That's only if you're kind of physically designing it, if you're physically drawing it. The way to think about these, and this is a skill you kind of need to spend some time practicing, because it's not the easiest thing to do, but is to almost close your eyes with it and visualize it and imagine to yourself, okay, well, if I'm going to fold these up, where I've got my edges here at the bottom with my base, those bits can't change, so the shapes around there almost need to pivot around these edges. So if I do that, if I think about that, okay, well, those are going to just be like that. So that then means that this face is going to fold up, and this face is going to fold up to here, and this face is going to fold up to here, and this one's going to come up to here. And what I'm going to wind up with is my fancy square base pyramid. And that just becomes a matter of practice. The difficulty comes when you get nets which aren't designed in the most straightforward way, and you need to kind of go through that practice then of identifying where the edges are, where those joins in those shapes are, because those are the bits that aren't going to move. And what you can then do in your mind is you need to be able to pivot those other shapes around it and see what's going to happen as it folds up. I've got a bit of an animation here on this page which will show us a bit of that. Again, with this animation is, as you can see, designed to be a packaging explorer. So this isn't necessarily for 3D shapes, but it's designed to show you what packaging looks like when it's folded out flat. So if you get something from Amazon, if you get something from a shop that comes in a box, if you buy yourself a Toblerone or a carton of soup, this is what the boxes would look like folded out flat. And what you can do is you can see them flat, but this is when I talk about visualizing how those faces are going to come together. This animation demonstrates that quite nicely. So that process of pivoting the faces around those edges is the process you need to do in your mind. This is a really tricky one. But through folding them up this way, you can kind of see how this is going to make this. Now we've got here, this is a tetrahedron shape. I can tell you that because there's 4 triangles involved. And you can see how that folds up. That process is what you need to do in order to understand what 3D shape a net is going to make. Okay, and if you don't have it physically in front of you, you need to practice that skill of folding things up in your head and almost close your eyes and imagine what that's going to look like when they come together. And again, remember that in this one and in the animations here, the red flaps that you're seeing here and the flaps that are here, those are simply there to create a physical 3D shape in the real world. Those are your tabs that you put your glue on. Mathematically, to create your net, you don't need those tabs there. But if you try to make a 3D shape without them, it's not going to work practically in the real world. Okay, the final thing that we're going to have a think about is area and volume. Last week we looked at area and we came to the conclusion that area is the length of something multiplied by the width. Okay, and for a square, if I had a square of 5, let's call that 5 centimeters. We know that because this is a square, the properties of the shape mean that this side is going to be 5 centimeters too. You'll also notice that by definition, square number. A square number is a number multiplied by itself. A square, the sides are the same dimensions, so that the area of a square is always going to be a square number. So length times width, 5 times 5 is going to give me 25 centimeters, but it's not just 25 centimeters, it's 25 centimeters cubed, and I can't get that on here, so I'm going to have to do a little workaround to get that up there. It's 25 centimeters cubed because I've done centimeters times centimeters, and anything multiplied by itself is that same thing squared, which is why you have to have centimeters squared for area. Now volume is very similar, so we're going to use a similar dimensions in our shape here. We're going to use 5 centimeters. Where's that gone? That's at the bottom, isn't it? 5 centimeters down here for our length of our base. We're going to use 5 centimeters for our width because it's a square. It's going to actually, it's a cube, isn't it? And then that means that if it's a cube, that means that all of my edges have to be the same length, which means that my height is also going to be 5 centimeters. Okay, so that's telling me here that I've got 5 centimeters this way, I've got 5 centimeters this way, and I've got 5 centimeters high as well. Now, if area was length times width, volume, bring that over to the right place, volume is the same as length times width times height. Okay, so volume is length times width times height. So if I pop this, let's put that in actual words. Volume equals length times width times height. Okay, so that's going to give me 5 times 5 times 5. So that's actually now a cubed number, and that's interesting in the same way that a square has an area that's a square number. A cube is going to have a volume that's a cubed number. You're spotting the mathematical links here with all of this, which is going to give me 5 times 5, 25, times 5, 125. So this cube here has a volume of, let's put it in the right place, thank you, 125 centimeters, but it's not centimeters and it's not centimeters squared, because again what I have here is I have centimeters times centimeters times centimeters, and if centimeters times centimeters was centimeters squared, centimeters times centimeters times centimeters is actually going to give me centimeters cubed, in the same way that 2 times 2 times 2 is 2 cubed. Centimeters times centimeters times centimeters, try saying that quickly 3 times, centimeters times centimeters times centimeters is centimeters cubed. Okay, hopefully that helps out with a bit of our background that we need to know for 3D shape, helps out with a bit of shape names, shape properties, shape net, and with volume. This is information that you're going to need to use this week for your maths. If there are any issues, if there are any problems, let me know and I will do what I can to help. Enjoy!